So this video is regarding the current and electricity for board exam. So we will see this chapter. So in current and electricity, we will see what is current. So current, that means electrical current, it is defined as the flow of charge or electrons. It is defined as the flow of charge, or we can say electrons. So generally in conductor there are free electrons. These free electrons, when it align in a certain direction, it will become the cause of electric current. So as we know that in metals or in any conductors there are free electrons. These free electrons move randomly when it is not connected to the external source. In that case, we will see that the electrons are moving in a random motion. If we know that, if we calculate the average speed of that motions, it will give like that velocity of electron. This is called thermal velocity. That is given by 3 kT by under root of 3 kT by m. This k here, this is Boltzmann constants. And T is temperature. So this is the velocity when the conductor is not subjected to the external source of energy. And m is mass of electrons. This is called thermal velocity. The average velocity of these electrons is considered to be 0 when it is subjected to the external source of energy. So when we apply some external source of energy, that is V, across the conductors, these electrons get aligned in a certain direction due to the influence of electric field established across the conductors. This electric field here is given by E equal to voltage per unit length. Due to this E established across the conductors, every electrons inside the conductor gets a force. That force is given by E into E. This force leads to accelerate the electrons in a certain directions. If we assume the direction of electric field from positive to negative, the direction of electrons here moves in the direction of electric field, but the direction of current due to the positive charge is always from negative to positive. So we will note down the direction of current. Direction of current in case of positive charge will be positive to negative. In case of negative charge, the direction of current will be negative to positive. So the current is generally caused due to the flow of electrons inside the conductors. These electrons inside the conductor constitutes current. Now the current is, it is defined as the flow of charge or electrodes. So generally the types of current we will see here. The current is generally two types. One is called instantaneous current and another one is called average current. Average current. So what do you mean by instantaneous current? The current at particular instant of time we call it as an instantaneous current. So I is given by dq by dt. This is the instantaneous current. The average current, when we consider the flow of charge in a particular interval of time, then it will become average current. Now in case of electricity, we have seen that any charge on body is given by Q equal to plus minus E, that is by the conjugation of charge. In general, if we define the current formula, that is I equal to Q by T, or further we can write I equal to plus minus NE by T, चूंकि Q equal to we have plus minus NE. So there are four formulas we have seen. Now first one is for instantaneous current, I equal to dq by dt. If you want to find the current at particular instant of time, when the charge is given as a function of time, we can find the instantaneous current. In case of average current, you have given an interval of times. So in that case, we will find the average current. In general, I is given by Q by T, that is charge by time. Now we will see the unit of charge. So the charge unit of charge, we know that is coulomb. So the unit of charge is coulomb. Now the current is Q by T. So coulomb, that is per second. That coulomb per second we call it as a what? Ampere, or it is denoted by capital A. So the SI unit of current is ampere. Now we will see the relation between drift velocity and current. So we will see what is drift velocity. This velocity is defined as the average velocity of electrons inside the conductor when the conductor is subjected to the external source of energy. If we calculate the average velocity of this, we will get the drift velocity. What is drift velocity? So we will see the term what is drift velocity. Drift velocity, it is defined as the average velocity of electrons inside the conductor when it is connected to the external source of field or energy. So it is defined as the average velocity of electron inside the conductor where it is subjected to the external source of energy. Source of energy. That energy in the form of electric field we can supply. So whenever the battery is connected to across the conductors, it establishes the electric field across the conductor. That magnitude of electric field is given by E equal to V by L. This electric field established across the conductor, and this electric field exert a force on electrons. That force is given by E into E. That is where E is the electric field and F is the force by which the electron gets drifted from one end to another end of the conductors, and that will lead to the current inside the conductors. So now, we are also mass. When anybody is moving with a certain velocity, it will create some acceleration. This force is also given by m into a. If we consider these two forces and equation 1 and 2, we will get F equal to, from equation 1 and 2, we get ma equal to E into capital E. And further we have know that this acceleration is given by rate of change of velocity. So this velocity we call it as a average velocity of electrons. That V is given by E into E by m into t. So this velocity is considered as an average because inside the conductor there is a collisions between the electrons. Number of collisions are occurring inside the conductor between the electrons. In this case, we will go for the average time or average path followed during the collision of electrons. So we will see what is the certain terms used in this case of average velocity, that is we are calling as a drift velocity. So that term we have come across generally will define free mean path. Free mean path. Second one is relaxation time. Relaxation time. So these two terms came. What is free mean path? This is an average distance covered by the electrons between the two successive collisions. We call it as a what? Average mean path, that is related by lambda. Now relaxation time is what? The time elapsed during the two successive collisions. We call it as what? Relaxation time. This is related by t. If we whole consider this term, the drift velocity in terms of relaxation time, we will get Vd equal to E into tau by m. This is the expression of drift velocity of electrons inside the conductors when it is subjected to the external source of energy. So what is E here? So here E is the charge on electrons, and T, that is tau, is relaxation time, and E is the electric field established, and m is the mass of electrons. So in board sometimes it will ask this velocity is average velocity or instantaneous velocity. We will tell it as what? In definition itself it is written here. What is that? Drift velocity is an average velocity of electron. Why we are assuming here average? So because inside the conductor there are so many electrons are moving randomly, and when we apply some external force, these electrons align in certain directions and it will go under the collisions. So we cannot find the instantaneous velocity at that time. In that case, we will go for the average velocity. We will consider the certain area over which the electrons are drifting. So that expression became here Vd equal to E into E tau by m. So now we will go for another relation between current and drift velocity. If we consider here a small area dx, the charge in that area, we know the current, instantaneous current, what is that? dq by dt. Here we consider a small area of length, area having A, and here the dx is the small elements of the conductors. So here the charge in the small segment of conductors, that is NEA dx. What is that? NEA dx. If I put this charge here, what you will get? D and NEA, what is that? dx by dt. So you get here I equal to NE dx by dt. Now dx by dt is called what? Velocity NEAVD. We call it as there dx by dt as an average velocity of electron, that we call it as what? Drift velocity. Just now we have seen that is drift velocity. So this is the one of the relations between current and drift velocity. This is the relation between current and drift velocity. Now we will come across one new point or new term in current and electricity, that is current density. So what do you mean by current density? Current density, it is defined as the current per unit area. It is denoted by J. That J is given by I by area. Here J, that is the current density, is a vector quantity. So J, it is a current density is a vector quantity. In differential form, we write here I is J dot ds into n cap, where n cap is the unit vector which indicate the